So hello, welcome to Build. Welcome to Seattle this year. For those of you that came from sunnier areas, thanks for bringing the sun to Seattle. We really appreciate it. My name is Marian Luparu, and I am the program manager lead for the C++ team in Visual Studio. And today we'll be discussing about Visual Studio 2017. There are several reasons that we'll go through throughout the session. We'll talk about the compiler improvements we're making. We'll talk about the productivity and the cross-platform support inside Visual Studio. But if I can summarize the talk, the goal of this talk is to show you how Visual Studio 2017 is the one IDE to provide you a full C++ development experience for every C++ developer, every app. Now, before we jump into the details, I do want to give you a quick map of the different releases that you're going to hear about, and you probably already heard about throughout the day today. So we released the final build for 2017 in March. Soon after that, in April, the update 1 of 2017 was available. Today, we have announced the second update. So this is the final build for the second update. Also, we have a preview of the third update coming up. And throughout the session, for every feature that it's not in a final release of a product, like it's not in the update 2, I'll specifically call it out so that you'll know to go look in a preview update or in a future update that we'll be releasing soon. So with that, let's jump straight into it, to the first reason. And that's our desire to write modern C++ code. There are many business reasons why we pick C++. There's the portability of C++. There's the performance. There's the power saving for the small devices. But really, at the end of the day, I think we all enjoy writing C++, and we all want to get better at writing C++. And what I do want to show you today is the progress the Microsoft team is making in the C++ compiler towards conformance. But this is a pretty busy slide, and I guess not every one of you are familiar with all the features in this list. So I want to take a small bit of time to delve into one single cell in there, just to give you a feel of kind of what are the things that are coming in the standard. So take 10 seconds and look at this source code. So if you were the author of this code, probably got some explaining to do, since you have a function that takes 2 pointers. There's just not enough information to understand how the function works. So if you were to consume this code, probably the next gesture, when you see this function showing up in parameter help or as you type it, would be to go to documentation or to go to the header to see that comment that developer left there. Like in optional, the second pointer, and the third one being an out parameter. Now, you can stop there, but I know some of you will go even deeper into the code and try to understand whether those semantics are actually enforced. Now, that takes a lot of time. Wouldn't it be nice if the standard would have something that will allow us to better express those kind of semantics? So enter C++ 17 and the optional type. And now you can express optional parameters. You can express optional return values. You can even express optional members of types. And you can see how this function changes, and it's a lot more expressive. The signature is obvious, but even the call site, I don't even want to look at the before there. It's so ugly, that call to the function. Here, it actually takes 2 items, and it seems reasonable. You can actually go one step further and say, well, if it's an optional parameter, the second one, I can actually make it I can pass on a default value to it. So that reads a lot nicer. You see like line 24 there. If you want to call it with one single parameter, that feels very nice. And the changes to the body are very trivial, really. And I'm sure some of you already noticed that this developer didn't actually took on to his promise that the third pointer is an out parameter because, hey, never gets set during the body of the function. And optional doesn't let you do that. So you have to either return null opt or the actual value that you want to return. So you see there, line 14 returns true, but doesn't set the pointer. So this is just one small example one single cell there on the long list of features. And again, let's get back to the busy slide. There are only a few things that I want to tell you about this slide. And you can use it as reference. The slides will be available later on. We have all the compiler has all the features in C++11 implemented. Same is true for C++14. And we're making great progress on C++17. And we will eventually catch up, and we're going to stay caught up once we do. Now, I choose my words carefully. I didn't say we're C++14 complete, because we still have one or two features in the old C++98 that are not yet implemented. And today we're announcing that we're actually going to release support for two-phase name lookup in 15.3 update. This is not in the first preview that you have today available, but it's going to be in the next preview. And it's going to be a partial support. We're fairly optimistic about the scenarios we currently support. And we believe by the end of this year, we will have full support for two-phase name lookup. And we'll hopefully be able to call C++14 complete our MSVC compiler. One more thing that I want to call out on this slide is the work we're doing with the TSs, with the technical specifications. There are two reasons why those are important. First of all, we want to make sure that the TSs that are available can be implemented in our compiler. So it's kind of an internal reason. But we also want to make sure that you have access to use those technical specifications in the real compiler and can provide us feedback, us and the committee feedback, before they actually become part of the standard. So I would encourage you to play around with it. Concepts is something that we're also starting to work on. So 15.3 will be a compiler that will have some very basic concepts support implemented in our compiler. But that's not, standards conformance is not the only goal when we think of modern code, right? You can write standard conformant code, but really ugly code. So Bjarne, when he announced the C++ core guidelines 2 years ago, created this set of guidelines for us to write better C++ code. One of the things that he specifically called out at the time was that we do need tooling for those kind of guidelines. So you can read that core guidelines. That's a very great read. I'm sure you're going to get a lot of ideas of how you can change the code. But we need to go further than that and actually provide tooling to recommend those kind of changes directly into the code. And we kind of, Microsoft took Bjarne on that challenge and started providing those kind of tools. So the C++ core checkers are part of the C++ code analysis. And they do an analysis of the code and do recommendations on how you can improve your code. And in 2017, this is actually part of the product. So if you just go to project properties into the code analysis tab, as you can see in the picture, you can turn on this type of diagnostics. And we also recently announced const check support. So this will be recommendations of how to make your code more const. And by extension, this will actually make your code faster. And soon, in 15.3, we'll announce resource management checks will be available in this static analysis. The guideline support libraries are just a header-only library that help you transition your code to be more compliant with the core guidelines. So I encourage you to try it. And I hope I got you a bit interested in trying out our compilers and our libraries. But I feel like there's still a bit of dread in upgrading to the latest version. You might feel that. And what would be some of the reasons that you would feel that dread? It would be maybe, hey, your code will not actually compile with the latest version. Maybe there's going to be a runtime issue. Maybe the third-party libraries that you depend on are not going to be available in 2017, so you're anyway stuck until everybody moves, and then you can move your code base as well. Well, I'm not going to give you that reason, and I'm going to put that fears to rest today, because one of the things that we're doing in 2017 is we're making it a pain-free upgrade. First of all, if you still need to compile your code with 2015, we're going to make it very easy for you to acquire that toolset right within the installer for 2017. You don't have to install a full 2015 product to get access to it. So when you start with a clean machine, you can still target that. And when you're ready to upgrade, we're obviously going to make it very easy in project properties to move to 2017. I'm going to give you one more reason why you should upgrade to 2017 compilers and libraries, and this is a big one. we're actually guaranteeing binary compatibility between the 2017 C runtime and 2015 runtime. And what that means is that you can forget about those third-party libraries that are stuck on 2015. You can take your code, build it with 2017 compilers and libraries, and link it against those compilers and those libraries that are built with 2015, and the code will just work. So there we go. You can do that today. And then I have another reason in case one of your third-party libraries is an open source library. Actually, I have 220 reasons, because VC Package now is a new package system that we provide that allows you to very easily install those open source libraries, those 222, via a very simple command, VC Package install library name. What that will do is download the source code, build it locally on your machine using the latest toolsets. And that is available both for 2015 and for 2017. So let's take a moment now, leave any dread behind of upgrading 2017, because I got a lot more things to show you in this deck. And I don't need any anxiety in the back of your head, please. So can we do that? OK, I see some not, so I'm ready to go to the next slide. All right, so we're going to talk about the developer inner loop now. And as I was talking with a developer, customer, Visual Studio, he coined the term the zone. This is where he gets into the code. He has a problem to solve. He figures out what code needs to be changed by moving around the code, and makes edit to the code. He compiles it, goes and tests it in case something fails. There's a diagnosis phase, and then once it's checked in, it's ready to go, and he moves on to the next problem. And this is how he defined productivity, how fast he can go through that cycle. And I know all of you are thinking in kind of the same way. You want to get to the problem through the cycle. And the Visual Studio team, we know how important this is to you. So in 2017, we're actually making improvements in all the specific areas. And we'll talk about this next. But before that, we're also making improvements in how fast we're trying to get you inside this developer inner loop. And that is the third reason I want to talk with you about today, which is the performance improvements we're making in Visual Studio 2017. And the way I would call them, I would use the word monumental. And I never used this word. I actually had to right-click on the word in Word and search for more synonyms until I got to it, because this is kind of how I want to describe the performance improvements we have in 2017. First of all, I'll start with the first line, if you are using external build systems, one good example is people that are developing games with Unreal Engine. The IntelliSense in Visual Studio doesn't have enough information about your PCH situation, so it will take a lot longer to parse the changes you're making in the editor. And that is not the case anymore. In 2017, we're going to create PCHs in the memory automatically for you, such that when you make changes, you can actually see them immediately in IntelliSense. So there will be a significant change. Now, not all of you are in that state, but all of you know that you don't want to waste a lot of memory when it comes to debugging. So that's one improvement that will benefit all of you. Regardless of how many PDBs you bring in memory, the consumption of the debugger, the memory consumption, will be much lower in 2017. Of course, it wouldn't be sufficient if we only talk about that and we didn't talk about faster builds. In 2015, we added support for debug fast link, and this was a significant improvement in the debug incremental builds that are happening in that inner loop. It was a 2x to 4x improvement in builds. Now, in 2017, because of the success of that, we're turning it on by default so that all of you are benefiting, not only those that attended the talk last year. And we're adding an additional 30% improvements when it comes to the build throughput in that scenario. But the biggest improvements are in solution load. And this is where we change the way we play the game. I'm using here an example, Chromium, which is a very convenient example because it's open source, so it's a benchmark that all of you can try. And also, it's huge when it comes to the size of the code base. And this is a scalability improvement that we make. The second time you load this solution in VS, you're actually going to get 17x improvement compared with 2015 release. And obviously, we could have stopped there, but we actually improved the memory consumption. So now when you load a project inside Visual Studio, it will be around 400 megabytes, 600 megabytes of memory that the dev.exe process takes. Obviously, Chromium is the large project, so it takes up to 800 megabytes. All right, so now we're ready to talk about productivity, and what better way to do that than through a demo. So what I have here is an open source project called OpenTDD, which is a clone of Transport Tycoon, which is a game I used to play when I was a kid a lot. And when I heard that it's open source, I thought about all the time I played and how I would have liked to make it to better suit the way I was playing it. So I was really excited I can actually go inside the code base and change it. But as you know, with every code base that you get from someone else, there are a set of challenges when you just want to start with it. So first of all is you need to figure out how to build it. Second of all, you need to figure out how the code is structured. The third thing is how to make changes to it without exploding the code base or imploding it. Either way works. And the fourth one is once you make those changes, to take them back to the owners and argue about the benefits of that code base. I have plenty of stories about the fourth part, and I'm sure you do too, but for the demo, I'll only cover the first three parts. So in this one, I'll switch to this, which actually lists the instructions on how to build this project with MinGW. And you can see that it has a lot of third-party dependencies. And if I scroll down, it has a long list of steps. And for someone that just getting started with this, this is a multiple point of failure throughout the process of actually building this project. And this is not specific. I'm not picking on this project in any way. Like, I think they're doing a great job of documenting. It's the nature of how C++ builds are. Now, if I were to look at the Windows instructions to use our compiler, they do a trick. They package all the binaries already in a zip file and hand it over to you to use, which is not something that I really wanted, because I really wanted to compile everything with 2017. So that was off the table. But what was on the table is VC package. So I went to VC package and looked at that list of library. And interestingly enough, I found all of them listed in there. And with this command, VC package install in the list of libraries, and I chose my architecture to be x64 in my case, I was able to build all of them. And once I was done, I run this additional command called VC package integrate install, which what this command does, it's listed here, it will add all the headers to my pound include path for all my MS Build projects. We'll also use all the static libs or import libs generated by my third-party libraries available to all my MS Build projects. And then what I had to do is go back here and build. And it worked. I have a project working, and I also made some changes that I want to show you. So normally, you would get, you can see the nice labels over there on top of the aircrafts and trains. I did that. I'm so proud of it. But you see, it has a bug, like if a train goes inside the tunnel, the label kind of remains here stuck until the train leaves the tunnel. It's kind of weird. The game engine does a good thing. It optimizes the position on the map of the train. But I'm exposing it in a very non-flattering manner. So I want to fix that. So let's fix that together. So I'll go back to the code. And what I really did is add this the sign member variable to a vehicle, and then figure out when to update it and when to draw it. And to show you how I did that, I'll right-click here and click Find All References. What this will take you to is to a dialog that has been completely revamped from 2017. So take a look as the results are trickling in, as the search is happening in the background, I can already start navigating through them. Also, we added new columns. So because this is a member, I can actually get all the reads and writes that are happening on that member in this list. And I can do more things. I can group by in this list. And if none of this fit my category, I can right-click here and say group by read writes, for example. If I want to filter the results, I can also go in and pick other categories that may seem relevant to you. We decided to default on the confirmed references, which means for us that we know that is the exact type. But you may want to pick looser terms when you search for those types. So that's one big improvement in 2017. And really quickly to jump to the code. So a lot of it is updating the position. This is the one that it draws. the label on the screen. And as you've seen, it draws it incorrectly. So I need to find out what is the right condition to stop drawing that label, so when it goes into the tunnel. And to find out where that location is, how could I do that, I'll just use goto, which is another new UI in 2017 that unifies all the code navigation operations inside an editor. So I can go to line inside this file. I can search for files. I can search for types or members or symbols in general, like types or macros or anything. I can limit the search to the current document if I chose to, or even expand it beyond my solution to anything that comes from pound includes. And all in this small little dialog. Now, I have some more settings that I could change, but what I'm searching for is something to do with vehicle and tunnel. And I only get 2 results. That never happens in real life, but you got to keep in mind that this is a demo. So the first example, the first piece of code doesn't look very promising, but the second one has a very interesting name. And if I scroll down to it, actually using the semantic colorization, something jumps at me immediately. There's a hide vehicle call, and then a hide reason that is getting set up. So that's great. That is the state I want to check for, and stop drawing my, my labels. So I'm going to steal that piece of code. I'm going to do some copy and pasting development here. And this is V, which is the vehicle, hide reason code equals track. And I'll just continue the loop and basically skip the drawing. So now I'll hit F5, and I know you're all on the edge of your seats to know whether the label will be drawn or not. And I hate to break it with you, but this code will actually crash, and will give me an opportunity to talk about the debugger features that we have. And hopefully we'll crash fast. So I have a breakpoint over here, and before it actually crashes, I want to show you another small feature, which is the run to cursor. This is very tiny. We already had run to cursor. You could have right-clicked here and pick run to cursor. But now you can actually hover over any line of code and click, and it will run to that position. Now it's not going to get to here because it's going to crash on the previous line. And something that you'll notice with the new UI we have here is that this UI is tied with the editor. So I can still navigate away from it and move to understand why this crash happened, which is a bit different how we used to do things in the past. And what's more important is that this is a longer expression, is v arrow hide reason arrow code, but the exception actually tells me exactly where the issue came in. I have hide reason is null putter. Now, since I'm in this UI, I'm going to show you another interesting functionality of it. Now, if you have any library that does exception-driven development, and it will annoy you while in the debugger by popping up an exception, you can filter it out. By the way, I hope the exception-driven development doesn't stick at the term. So, OK, those are the features that I wanted to show you in the debugger. Clearly, we're on the wrong path with this usage. So let's go back to the tunnel bridge here and hit Alt F12 to do a peak definition inside hide vehicle. So now we know why it's crashing, because that hide reason is different than null only when the train is invisible. So for all the visible trains, we are crashing. But this looks a lot more promising. So I'll copy this, this function, right? And this is the exact condition I need. So I'll paste it in here. And what this will give me is the opportunity to talk about a new feature inside Visual Studio called predictive intelligence. You see how this only lists some of the members of the vehicle type. If I hover over it here, the context in which I'm in is that is vehicle hidden takes a VH status parameter. And in all the members that the vehicle class has, there's only one with that exact same type. So I don't have to deal with the long list of members. But if I need to, I can always expand out of this context-aware results and drill into the full list of members. Because usually there's a long list. We also added functionality to make sure that we can filter between variables, functions, and these are sticky buttons. So you can select as many as you want. And the more categories you have, the more buttons are going to show up at the bottom. But for this case, this example was perfect. So if it's vehicle hidden, I will just hit continue. And now I think we have on our hands a patch that is ready to be sent to customers, and to the authors. That's a longer story. So what I want to show you next is the fact that I have a lot of more ambition to this code base. So I'm starting on the side to add code, and I'm prototyping things. And I'm yet not ready to bring that code inside the big project. But when something works, what I do is start writing a lot of tests for it, because when I actually bring it inside the big project, I'm sure I'm going to break it because of all the changes I need to make it adapt to the existing code base. So I write unit tests. I'm not particularly picky about the unit test framework I pick, but for this particular reason, I could not use MS Test. I needed to use something that is cross-platform, because OpenTDD is a code base that runs on many, many platforms. So I pick Google Test. And I have a few tests here defined with Google Tests. And there is no reason why I would have to leave Visual Studio to go and run those tests on the command line. And that's something we're announcing today, the support for Google Test inside Test Explorer. So I can just run them from here, just like I would run MS Test tests. And as soon as it builds, it will run my test as well. And you can see one of them is failing, conveniently. And I have a breakpoint here. And debugging is a familiar experience as well. I can debug selected test. I will hit the breakpoint as soon as the debugger loads its symbols. And if I step over it, I can see that the return value for this one is actually, they found a solution and I was expecting null opt. So we'll fix this later. But I'll switch back to the slides for now, because I want to talk a bit more about our unit test announcement that I just made. So the goal is to have you use any unit test framework from inside this IDE. Whether this is the MS Test, which is Windows-centric and it works in UWP and it works in Windows, whether it's Google Test, which is cross-platform. And we want this all baked in inside Visual Studio so that you don't have to install additional tools. For now, though, this is just an extension in the marketplace. And this goes to the point of how lucky we are that we have such a rich ecosystem. When we first started to look at this, we found a great extension already written by Christian and Jonas. And we'll be starting talking with them, we're collaborating. And we actually think this is a very solid extension that we're ready to bring inside the product. So that's the first step we're taking. We're making this extension available in Marketplace. Please go to ak.ms CPP testing and download it. Give us your feedback. Give Christian and Jonas your feedback. And we want eventually this to be part of the product together with Boost Test and any of the other popular unit test frameworks. OK, so that's our productivity story. And as I mentioned, we have improvements across the whole inner lifecycle, the whole zone. Whether it's for reading and writing, we have new predictive IntelliSense, go to find all references. When it comes to compiling, there's faster builds. For test, we have unit test frameworks. And for diagnosing and committing code, we have a long list of features in Git and debuggers, and even in the compiler with the compiler diagnostics. Now, I know that there's some of you out there, I'm looking at the camera, not you here, that are not using Visual Studio today. And one of the reasons might be that you don't have Visual Studio solutions, you don't have MS Build projects, and you think that none of the demo that I just showed you now applies to you. Now, I'm here to change your mind, because in 2017, you can open folders containing any C++ source code, whether that has VS Solutions or not, directly inside VS. Open folder is ideal for non-MS Build projects, and it's very easy to get started. You just type devenv and the folder name, and devenv will load that folder, will parse all the source code, and will make it available to you. You can start editing immediately. Now, you can buy it as much as you can chew. You can configure, for example, for a great IntelliSense and browsing experience. And you get all the features that I mentioned, that I demoed earlier, through some small configuration. Or you can write a small task to teach VS how to build your project. Or you can run some small launch configurations that will teach VS how to debug your project. Or you could do all three, and you get a full inner dev loop. Now, for CMake, CMake is a special case, and we actually do a lot more than allowing you to configure it. Can I get a quick show of hands? How many of you are actively developing using CMake projects? Oh, a fair share. Please keep your hand up. How many of you have tried CMake? OK, great. How many of you have heard of CMake? OK, the last question was just to check whoever stumbled in accidentally into this room. I appreciate for raising your hands. If you got dragged in by a C++ developer into this session, remember it's a 300 level session. So take your cues from the C++ developer when you fill in the evaluation. So let's look at the CMake demo. I'll switch back to my machine. And what I have here is another open source project called Bullet. You're probably familiar with it. And the moment I typed in devenv dot to open the folder, or I could have went here to open folder, immediately I could start editing the CMake scripts. I could start editing the C++ code. But something that happened in the background when I did that is that Visual Studio started configuring the CMake project. And then after it's done, read information from the CMake cache to bootstrap the Visual Studio services. And what Visual Studio services I'm talking about? Well, first, there's the language services, IntelliSense, browsing. All those functionality, once the CMake project configured successfully, are available to you. All the navigation, all the predictive IntelliSense that I demoed earlier, just like you would have an MS Build project. You can also right-click on the CMake list, and you can choose to build it. That's already information that we make available to you, no configuration needed by you. So this is the full list of targets that are defined in the Bullet project. You can build all of them. You can build one of them. You can also install, clean. You can run all the tests. So if you have C tests that are authored inside your CMake lists, here's where you would just run them. And finally, you can debug any of the executable targets. To show you really quick, this is in action. You can also change it from the debug target dropdown. And I hope this is up to date. It will start the project. And again, like there's no configuration, additional configuration you need to make as soon as the CMake configure steps finish successfully. Now, some CMake projects require some additional settings to be passed, like third-party libraries or modes in which you need to build them. If you know what is your CMake command line, it's very easy to take that and put it inside this nice configuration file that I just opened by right-clicking on a CMake list and say change CMake configurations. So you paste in the full command line over here, and now you'll get all the functionality in it. So configuring it is very simple. You can select the generator. You can select the configuration type. You can select the build route where all the CMake caches are placed. You can even configure the build command line, pass additional settings to MS Build, or the ctest command line if you like. Now, really quickly for the generator, for those people that are actively using CMake today, which would be one generator that you would like to see in this list? Shout it out. Shy crowd. What? Yom. Mm. Interesting. Well, I was hoping that you're going to say Ninja. So Ninja is a build system that CMake knows how to generate files for. And it's got different advantages and disadvantages compared with MS Build. And it's something that a lot of customers have been asking us since we shipped the first version of CMake support. And to show that, I have here at the end another configuration. Again, something that I should have mentioned. You can create as many configurations as you want. And then you can easily switch between them from this dropdown. So you can see I said generator Ninja. I configured the build command for Ninja. And now if I switch to it, in the output, CMake will actually run Ninja. And as soon as the configuration finishes, Visual Studio will read all the information it needs for the language services, for debugging and building, even though the project that gets generated there is not an MS Build project. All right. So we talked about adding more unit test framework support to Visual Studio. I also showed you how you can use Visual Studio as one IDE regardless of the build system you choose to use, whether that's MS Build, whether that's CMake, whether that's Ninja. And now next we'll talk about how you can use Visual Studio as one IDE regardless of the platform you're targeting. Of course, Visual Studio supports targeting Windows and UWP. And by the way, UWP means mobile devices, desktop, Xbox, and HoloLens. But we also support Android, iOS, and Linux inside the same solution. For Android specifically, we have a great experience editing C++ code, building, and debugging C++ code. And probably less known, we also have an experience for editing, building, and debugging Java code. When it comes to iOS development, we want to make it as easy as possible to bring your code base from Xcode and load it inside VS to take advantage of the C++ language services we offer. And this could be the start of you taking their iOS app and making it cross-platform. You could now start targeting Android, start targeting the mobile devices on Windows, and so on. And then this is not a prisoner situation. Once you come into Visual Studio, you can always go back to Xcode for the operations that are not supported inside Visual Studio, like storyboarding or localization. And you can always come back and forth between the two IDEs. And for Linux, 2017 is an important release, because this is the first release where the Linux development is part of the Visual Studio product. Now, the requirements we have on the Linux distro when you want to use the Linux support are not higher than any developer activity you need to make on Linux. You would need a GDB server, you need a compiler, and you need an SSH to connect to it from Visual Studio. And to showcase that, I'm going to switch again to the machine, and I'll do a quick demo. OK, so what I have here is a solution with two projects conveniently named Windows Cube and Linux Cube. Now, something that you'll notice is that they don't have any files in them, because they actually have a reference to a shared project. The shared project has my source code in it. And what this means is that this file is going to get built both in the Linux project and in the Windows project. So I have selected here the Windows Cube, and I'll hit F5 really quickly to show you what this does. And this is a spinning cube, but it kind of spins really fast. So what I'm going to do now is maybe tone it down a bit. So let's add 10 milliseconds. And as soon as I click Save, something that I, as a developer, don't know yet, Visual Studio already knows that sleep is not a function that is available in Linux. So if I hover over this, you'll notice that the error for the the purple squiggle is coming from the Linux context, and it says that sleep is not identified there. So to fix this problem, I'll just have to add some Windows-specific code. And I happen to know, though, that there's a function called usleep over there on the Linux land. But too few arguments in the function call, I get an error from it. So what I'll do now, to actually get Linux IntelliSense, I'll switch the context from the top drop-down over there and switch to Linux. And if I bring up the parameter help again, I'm actually getting full IntelliSense from the Linux headers now. And it's good because it's actually a microsecond parameter, not a millisecond. So I need to add a few more zeros, I hope, if my conversion is right. So now we're ready to build it on the Linux machine. So let me set the Linux Cube as a startup project. And you can see the debug target at the top changing. Now it tells me that this is going to be a remote build. And to show you how I configure this, I'll go really quickly to the connection manager over here. So this is tool options, connection, cross-platform connection manager. And what I did here, I already configured my Linux machine, connecting it to my Windows machine. You can add as many Linux machines to your configuration, and then you can use them for building and debugging. And this is the one that is running in a VM. So I'll just hit F5. Let's see if we can see it running. By the way, the sudo apt-get is the command I had to run on this Linux machine to enable this experience. That is the requirement that I was mentioning earlier. So there you go. Magically, the spinning cube transitioned from my Windows machine to my Linux machine. And this is a full debugging session. So there you go. I already hit the breakpoint, and this cube is frozen for now, because I want to show you another functionality here that you're very familiar when you're doing Windows debugging as visualizers. In Linux, this is kind of how the type looks like. This is what you would get. But in 15.2, the update 2 for 2017, we're adding visualizers for Linux for most of the STL types, so that you can get a visualization like this, like you're familiar with Windows. All right. So now let's look a bit in the future. We are doing a lot of work to make sure that you can use Visual Studio to target any platform, to target using any build system, regardless of the frameworks or libraries that you depend on. And let's imagine what else we could do beyond this functionality. So I want to ask you, CMake had a great year, right? We added support for CMake inside Visual Studio. And they announced 3.7 release. They announced 3.8 release, which brings a lot of support for new languages inside CMake, as well as support for the C++ standards, allow you to configure. Now, wouldn't it be nice if we can take it one level up and up a notch? So let's imagine, and let's see if this is going to work. We're back to the Bullet project that I was demoing earlier in CMake. Now, wouldn't it be nice if I can go in that configuration file where I initially said Ninja and say that I want to build this on the remote machine, on my Linux remote machine. And I want to use the Unix makefile generator. And I want the source code to be copied to my home machine, to my home folder, and my CMake cache to be generated somewhere in a temp folder. Wouldn't it be nice if this would work? So I'll switch now and see what happens. This is running on the Linux machine. And just as you've seen for MS Build projects, now we're announcing that we will be able, with CMake, to do the same thing. You can see the CMake running in the background, and it's using the Linux path. And when the configuration is done, as you can see from this message with build files being saved to the temp file, what Visual Studio does, it goes remotely and asks CMake for all the information that we need to bootstrap our language service, our building, and all debugging. Now, we only have build working so far. This is a prototype. These are very hot bits that I have over here, so I'll use them with care. So when I click Run here, the build will start. And this is actually using Make on the remote machine. And to showcase that, I'll have to go to the var. So it would be in the basic demo. And you can see the CMake scripts over there. It's still going to take a while. So while this build is going on, I want to clarify what's going on. So now, in addition to MS Build being able to target Linux and Windows, using CMake, which is a cross-platform build system, you can target both platforms. This is something that's going to come in the next release. So it's not going to be in the 15.3 update, but we're working very hard on enabling the end-to-end. I just wanted to give you a glimpse of the things that we're working on to make your life as easy as possible to target as many platforms as you can. And I think this is not going to finish, but you'll have to trust me that a binary will magically show up in the var temp, and if I launch it, you'll see the same bouncing boxes. And I'll love you if you stop by the booth later on, and I can show you this demo real on. All right, so we talked about the compiler. We talked about how we make it simple for you to upgrade, and we make it fast for you to get into the inner loop with the performance improvements we're making. And once you're in the inner loop, we make you very, very productive. Wouldn't it be nice if all this came in a nice box with a bow? Well, metaphorically speaking, it actually does, because Visual Studio comes with a reimagined installation experience. It has been redesigned from the ground up to actually give you the workloads you need and save you from the installation time of anything that you don't use actively. So first of all, you'll benefit from a faster installation. If you're installing the C++ desktop workload on a good enough machine with a good internet connection, you will be able to install it under 12 minutes. Now, this will also have a smaller footprint on disk. So you're not getting any of the bits that you're not using. And the third benefit is that click the wrong button, is that there's going to be less visual noise inside the IDE, because if you're not installing the ASP.NET workload, you're not getting any ASP.NET templates, for example. You're not getting any of the context menus that some other workload is adding for you. We provide 5 workloads in Visual Studio. There's the desktop, universal, mobile, game development, and last but not least, the Linux development experience. All right, we're getting close to the end of the session, and I want to talk about one last reason that is very dear to me. One of the reasons you should be using Visual Studio 2017 is because you helped build it. We listen through many channels. One of them is user voice for suggestions. Another one used to be Connect for issues, and now it's report a problem from inside the Visual Studio IDE. And all those issues get routed to developer community Visual Studio IDE. We get a lot of feedback, and it's very humbling to see your passion for this product, and we're as passionate as you are. So we're trying to fix as many problems as we can. Can I get a show of hands how many of you reported ever an issue through these channels? Thank you very much. I actually couldn't imagine how this product will actually look like if you didn't have done that. So thank you. Please, everybody, give them a hand of applause. Thank you. So these are the stats for 2017. And with that, I'm gonna wrap it up this session. So we talked about compilers and the improvements we're making in conformance. We talked about how easy it is to upgrade, the performance improvements we're making, and the productivity features that we added. We're also making it easier for people that are not using Visual Studio to come in Visual Studio and start taking advantage of all these features that I mentioned above. And we're targeting all the platforms that you need to satisfy your requirements. So if I can summarize it in one sentence, I want to say that Visual Studio 2017 is one IDE that gives you the best C++ experience, regardless of the build systems you're using, regardless of the libraries you depend on, and regardless of the platforms you're actually targeting. With that, I want to thank you for coming here today. Have a great rest of the build. Thank you.